Therefore, volume of water flowing through
64.
the pipe in 1 minute. That was the question. So in 1 second for 140 centimeter cube. Therefore, in 60 seconds it is into 60.
64.
Okay, so this is 640 centimeter cube. Right? Any question till this part? This is the volume of water flowing. Now, anyone knows the relation between centimeter cube and liter? If it is given,
Yes, sir.
give you
1
an
liter. So
Sir,
1
1
liter is equal
centimeter
to
cube
1
equals to 1
centimeter
liter.
cube.
yes. If it is given to you, give you answer in liters. Like then you can convert this to liters as in the following manner. Like say we have 1000 centimeter cube is equal to 1 liter. Right. That means 1 centimeter cube is 1/1000 liters. So that means 640 centimeter cube is 1/1000 into 640 liters. You can cancel this and you can cancel this also with 25/1/6. So this is 16/25, which is 0.64. Yeah, yeah, 0.64 liter. We could have done it from here only, but anyway, this is 0.64 liters. If they ask you give your answer in liters, or if they give you in the problem take 1000 centimeter cube is equal to 1 liter, then this is the way you are going to proceed. Okay, so that is what was this question all about. We see the next question, that is 26a. 26a, there's a figure given there in question number 26a, and you need to find out the volume of that figure. Okay, it's a three-dimensional figure. Let's see here. This is your figure given here. Okay, this is your we are talking about this figure here. Okay, this is inverted, but if you have your textbooks, it should be better. Okay, now what is given here is that the figure given below shows a solid uniform cross section. Okay, find the volume of the solid. All measurements are in centimeter and all angles are right angles. Okay, so here if you see in this figure, all the measurements are given 4, 2, 2, 6. Okay, all these measurements are given. But what you must realize here, in order to, and they have asked you to find out the volume. Now, see that if you want to find out the volume, it looks a little complicated, right? It looks a little complicated. That is, you have two cuboids, and then you have to add up the volumes of these two cuboids. Then you have to subtract the volume of a cuboid. But actually, this, if you see, this is a solid with a uniform cross section. And how does the cross section look like? If you see, the cross section looks like this L. If you see, the cross section of this solid looks like L. Can you see this or not? Tell me. Can you observe this L here? This cross section? And what are the measurements? Yes, tell me, can you see this cross section or not? Can you see this part of the figure? Let me just shade this.
Yes, sir.
This L part. That is what I've drawn here. Can you see this L part?
Yes, sir.
This is the cross section of this figure, because from whatever part that you cut this figure, even if you cut the figure from here, you will still get an L. You cut the figure from here, you'll still get an L. So this L is actually uniform throughout this cross section. Throughout this cross section. Right? Throughout this you will get an L. And what else is there? This L is there, and then you have a certain length in this part here, something like this, isn't it? You have something like this. Okay, we are not bothered about this right now. We'll only be bothered with this L for the time being. We are only bothered with the cross section. Okay, we are going to find out the area of this cross section. Okay, we're going to find out the area of this cross section, this part. And how to find out the area of this cross section? Let us look at the measurements that are given here. The measurements that are given here are, this is 6 centimeter given, 6 centimeter, this entire length is 6. Okay, what else is given? This length is given to you as 2. The unit is not given, they just mention it all in centimeters. Okay, so this is 2 centimeters, this is 6 centimeters, and you are required to find out the area of this cross section. So can anyone tell me how to find out the area of this cross section, this green shaded part?
No, sir.
Why is it so difficult? See that you complete this. Okay, so this also becomes 2, right? This entire length is how much?
Yes, sir.
6.
6. This entire length is 6. That means this length becomes how much?
4 minus
6 minus
2.
2,
6 minus 2. 4.
which is 4, right? So you can find out the area of this rectangle. You know the length as 4 and the breadth as 2. You can find out the
2.
area.
Yes. Yes, sir.
Similarly, you can find out this area, right? 4 into 2,
Yes, sir.
because this length is 4, right? And this is a square. This red square that is there here, this part, this is a square of side 2 centimeters. That's it. Area of the two rectangles plus the area of the square. So let us proceed to find out the area of the cross section. Area of the cross section is equal to area of the vertical rectangle. Let us consider the vertical rectangle first. Area of the vertical rectangle is 4 into 2, right? What is the area of this horizontal rectangle here? This part. It is again 4 into 2.
Sir, 6 into 2.
4 into 2. We are only considering this part.
Oh, yes.
Okay, we are only considering this part. That is why 4 into 2. So 4 into 2 plus 4 into 2. And what about the red shaded square? It is square of side 2. So this is 2 square. So this is the area of the cross section. So this is 8 plus 8 plus 4, which is 20 centimeter square. This is the area of the cross section. Now the point here is that if you want to find out the volume of this solid, what is the formula for volume of the solid? Area of cross section into length. What is the length? And now we will consider this part. Now we'll consider this part. This part. This is the length part, right? If we have considered L as the cross section, then this is my length, this part. And how much is the length given here? The length is given to you as 4 centimeters. So what is the volume of this cross section? The volume of this solid. Hence, volume of the given solid is equal to area of cross section into length. Area of cross section we have already found out. Area of cross section we have found out to be 20 into, and the length here given here is, if you see what is the length given here, 4. So this length here is 4, and by length here means this length. Because we have considered this L as our cross section, this becomes our length. This into 4 becomes 80 centimeter cube. This is the volume of this. Otherwise, if you have used the cube and cuboid formula, this would have become very difficult, because You have to find out the area of this cuboid. Okay, this cuboid here. Then you have to find out the area of this cuboid. Okay, it's all become very confusing. But the advantage here was that we had this solid was of uniform cross section. So we applied the formula area of cross section into length. That is what. And the next problem that we are going to do is also quite the same as this problem, but except that the figure of the solid is not given to you. You have to imagine the figure of the solid. And that problem is the last problem, that is 26C. This problem, this figure here. Okay. If you look at this figure, this looks like a trapezium actually. It is given here that the figure given below shows the cross section of a swimming pool 10 meters broad, 2 meters deep at one end and 3 meters deep at the other end. Calculate the volume of water it will hold when full, given that the length is 40 centimeter. Now this is an easy diagram to draw. So let me draw this diagram. This is not a three-dimensional diagram. I'll draw this diagram and explain.
Sir, it is a trapezium, sir.
It is a trapezium. Okay, so you have this kind of a figure here. This is a cross section of a swimming pool. What do you mean by cross section of a swimming pool? Can you tell me what uh, what kind of cross section we are talking about?
Rectangle.
Hmm? No, what cross section means? What kind of a view is this?
What? Quadrilateral trapezium.
No, from where are we viewing the swimming pool? From where are we viewing the swimming pool? That is the
top.
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 Top, sir.
Yes, you
Yes,
can
sir.
say top. You can say an aerial view of the swimming pool. This is your 90-degree angle, these two. This is given to be 2 meters and this is given to be 3 meters. Okay, this is the floor of the swimming pool. This line that you see, this is the floor. Okay, it's an inclined floor. So what happens when a person is standing here? Okay, so when he goes down, he's actually going deeper into water. Okay, so that is what. And now let us see what is given. The figure below shows the cross section of a swimming pool 10 meters broad. 10 meters broad. What do you mean by 10 meters broad? Is 10-meter measurement given here in the figure? No, it is not given. 10-meter broad now means that the swimming pool has this much, this
Sir,
kind of a length.
height.
This kind of a length it has. Okay. It looks something like this, say. The swimming pool looks something like this. Understood? You understood what I'm trying to tell you? Swimming pool looks something like this.
Yes, sir.
So it is 10 meters broad here. This length is 10 meters. So that the cross section of the swimming pool is your this part. Okay. This is your cross section. Cross section is in the form of a trapezium. So 10 meters broad, fine. 2 meters deep. 2 meters deep it is already given to you here. The shallow part is 2 meters deep here. Okay, when the person lands here, it is 2 meters deep at one end and 3 meters on the other end. And as he is going down into the swimming pool, this becomes 3 meters in depth. Okay, he is going deep into the water. Calculate the volume of water it will hold when it is full, given that the length is 40. So this length is given to be as 40. Okay. So what we are going to do here is we are going to first find out the area of the cross section. This shaded part is your cross section. So area of cross section of the swimming pool. What is the area of the cross section? It is area of the trapezium, right? Of trapezium. And what is the area of the trapezium here? Half. Sum of the lengths here. This length this length. 2 plus 3, sum of the parallel sides, these two are parallel sides, into height. And what is the height here? Height here is 40. So this is half into 5 into 40. This is 100 meter square. The area of this, the cross section here is 100 meter square. So therefore, what should be the volume of water in this pool when it is full? Area of this cross section into this length, right? This length here. Therefore, hence volume of water it will hold when full is equal to area of cross section into length. Area of cross section we have found out to be 100. And what is the length here? This distance, this length here is 10. So this is 1000 meter cube. Clear? 1000 meter cube. How many meter cube is 1 liter? Can you tell me? How many meter cube
Sir,
is 1
1 by
liter?
100.
1 by 100. Yes. 1 by 100 liters is 1 meter cube. Okay, so if you want to express it in liters, you can also express it in liters. But in most of the cases, they will not ask you unless they will give you the conversion. They will tell you take 1 meter cube is equal to 1 by 100 liters, or they will tell you that take 100 liters is equal to 1 meter cube. Then only they will ask you to convert it to liters. Okay, so this is the end of the chapter here. Unless you have any other problem from this chapter, any other individual problem, I will conclude this chapter here. The distance between 2 points A, x1, y1 and B, x2, y2 is AB equal to square root of, this is the formula. Distance between 2 points whose coordinates are given to you as x1, y1 and x2, y2 is root over of x2 minus x1 whole square plus y2 minus y1 whole square. Sometimes, uh, and quite sometimes, this is almost the same. You can also write the formula as x1 minus x2 whole square, because once you have a square, you can interchange x1 and x2. You can also write this as y1 minus y2 whole square. Any way you want to remember, whether you want to remember this way or whether you don't want to remember this way. But remember, the order of the coordinates is important. So let us take a very simple example to start with. The question here is, find the distance between the following points. Find the distance between the following points. The first point is 2, 3 and 4, 1. The first point. And say the second point is minus 5, 7 comma minus 1, 3. Okay, so let us start with the first one. 2, 3 and 4, 1. Okay. Let the given points be
तो देखिए पूरा देख लिया, मजा आ गया। पबजी अनबैन कीजिए पहले।
let the given points be A 2, 3 and B 4, 1. These two are the given points. Okay, so therefore what is the distance AB? We want to find out the distance AB. What is the distance AB? We know this to be root over of x2 minus x1 whole square plus y2 minus y1 whole square. So we consider this as our x1, this as our y1, this as our x2, this as our y2. So here, what is x1? x1 is 2, y1 is 3, x2 is 4, and y2 is 1. Remember, x1, y1 and x2, y2 should always be taken very carefully. It's not that you take this as your x1, y1 and then while calculating you take this as your x1, y1. No. Okay. Try, if possible, write in pencil which one you are taking as x1, y1, which one you are taking as x2, y2, and later you can erase this. Okay. So here, therefore, AB will be root over of x2 minus x1, 2 minus x2 is 4 in fact, 4 minus 2 whole square plus 1 minus 3 whole square. So this is root over of 2 square, 4 minus 2 is 2 plus 1 minus 3 is minus 2. So this is root over of 4 plus minus 2 square is also plus 4. So 4 plus 4, which is square root of 8. This is a pure surd converted to a mixed surd. This is 2 root 2. Okay. 2 root 2 units. This is the distance between these 2 points. Now suppose for the second one, again let the given points be P minus 5, 7 and Q minus 1, 3. So what is the distance PQ? Therefore PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square, which is root over of, now let us take again, let us see which one is x1, y1, x2, y2. Let us write it. This has x1, this has y1, x2, y2. So here x1 here is minus 5, y1 is 7, x2 is minus 1, and y2 is 3. Okay, so therefore PQ is square root of x2 minus x1. x2 is minus 1 minus x1. Now minus x1 means minus of minus 5. It will become plus 5. So so I introduce a curly bracket here. So x2 minus x1 square plus next y2. y2 is 3 minus y1 whole square. That's it. Equal to square root of, this is minus 1 plus 5 square, and this is 3 minus 7 is minus 4 square. So this one is square root of 5 minus 1 is 4 square plus minus 4 square. So this is root over of 16, and minus 4 square is also plus 16. So 16 plus 16. Be very careful with the signs when working with distance formula. Root over of,
So we can't just cancel the square and root.
no, because there's a plus sign you cannot cancel. If it had been a multiplication
Okay.
sign, then you could have. Understood?
Yes, sir.
So root over of 32 means root over of, if you prime factorize 32, you'll get 2 to the power of 5, I think. Right?
Yes, sir. 2 to the power 5.
which can all now be written as root over of 2 square
2 root 2.
into 2 square into 2,
Yeah.
which will now become 2 into 2 into root 2, which is now 4 root 2 units. Understood? That is what. Similarly, if you see, this is nothing but 2 cube, right? So it has been written as 2 cube can be written as 2 square into 2. So this is root over of 2 square into root 2, which is 2 root 2. That is why. Okay, root 8 mostly people remember it as 2 root 2. Clear? Distant formula or any questions on distant formula? Go through these
No,
two.
sir, no question.
Go through these two examples. Okay, and as I told you, while using distant formula, be careful which one you're taking as x1 y1, which you're taking as x2 y2. Be very careful of the sign. See, I have taken x1 with the sign -5, -1. Okay, and while putting it in the formula, also you have to be very careful. That is why I'm saying when you're writing x1 y1 and x2 y2 here, if possible, write with a pencil. Which one is your x1 y1? Which one is your x2 y2? And after putting in the formula, you can erase it. Okay, or after the end of the sum, you can erase it. Understood? So be very careful with the signs. Be very careful with which coordinates you are taking as x1 y1 and which coordinate you are taking as x2 y2. You are free to take anyone. In fact, I have taken this as x2 y2. You can take this one as your x1 y1 also. Okay, and you can take this as your x2 y2 also. Okay, but be careful with the order. Not that if you have taken this as x1 y1 and this as x2 y2, but in the formula you are considering this as your x1 y1 and this as your x2 y2. Not that way. When you're starting with some x1 y1 and x2 y2, stick to that. And of course, be very careful with the signs. That is, when you're putting, considering the signs, okay, it's like here, I've got minus and minus have combined to become a plus here. This kind of mistakes you must be extra conscious of. Okay, so I stop here for today.